All right. Network Working Group, C. Newman, Internet Draft, Network Byte Order, Inu Soft, Document Draft, Newman Network Byte Order 01.txt, February 1999, Network Byte Order. Status of this memo. This document is an Internet draft and is in full conformance with all provisions. See Section 10 of RFC 2026. Internet drafts are working documents of the Internet Engineering Task Force, IETF, its areas, and its working groups. Note that other groups may also distribute working documents as Internet drafts. Internet drafts are documents valid for a maximum of 6 months and may be updated, replaced, or obsolete by other documents at any time. It is inappropriate to use Internet drafts as reference material or to cite them other than as work in progress. The list of current Internet drafts can be accessed at http://www.ietf.org/ietf/1id-abstracts.txt. The list of Internet draft shadow directories can be accessed at http://www.ietf.org/shadow.html. Abstract. This memo defines the term network byte order and explains why it should be used in IETF protocols and media types. 1. Terminology used in this document. The keywords should and should not in this document are to be interpreted as described in keywords for use in RFCs to indicate requirement levels. Within square brackets, keywords. A byte is the smallest natural grouping of bits that can be directly addressed by hardware. Modern hardware and network protocols use 8-bit bytes, also known as octets. End of page 1. Internet draft, network byte order, page 2. 1.1 Background and motivation. The document On Holy Words, A Plea for Peace, IEN-137, written in 1980, argues that the industry should settle on a single byte order. Since then, IETF has largely settled on a single byte order, known as network byte order, and this memo is intended to record that rough consensus. Unfortunately, the holy war continues among CPU manufacturers. 2. Definition of network byte order. When a number is too large to fit in a single byte, multiple bytes are used to encode that number. When such numbers are sent over a byte-oriented protocol, e.g. TCP is 8-bit byte-oriented, an order for the bytes must be selected so both ends interpret the numbers in the same way independent of CPU architecture. When the bytes which make up such multi-byte numbers are ordered from most significant byte to least significant byte, that is called network byte order or big endian. So let me say that again. When bytes which make up such multi-byte numbers are ordered from most significant byte to least significant byte, that is called a network byte order or big endian. For example, take the unsigned hexadecimal number 0xFEED FACE decimal 4,277,009,102. If this is sent as a sequence of 8-bit bytes using network byte order big endian, the sequence would be 0xFE, 0xED, 0xFA, 0xCE. In little endian, least significant byte to most significant byte, this would be 0xCE, 0xFA, 0xED, and 0xFE. Byte order recommendations. The following byte ordering options have been used in protocols or media types in the past. 1. Network byte order only. 2. Little endian only. 3. Runtime selection between 1 or 2. In practice, runtime selection has often been a failure. It adds a negotiation step and creates two variants of the same protocol or media type which have to be tested independently and often aren't, so things break. A well-known case of 3 is the TIFF media type, TIFF. Versions of TIFF software were released which only handled one of the two byte orders. Because of this, most modern TIFF software gives the user a choice between the two TIFF variants and calls them Mac format, big endian, and PC format, little endian, in an attempt to make the problem partially comprehensible. In this case, 3 resulted in interoperability problems, extra user interface development work, and user confusion. Even the risk of such serious consequences outweighs the minor benefits used to promote 3. Therefore, at runtime, byte order selection should not be used. Choice between 1 and 2 is arbitrary given that the cost of byte reversal on modern processors is nominally negligible. However, IETF protocols and media types should use network byte order both for consistency with existing IETF work and also to take advantage of the network byte order macros NTOHL, HTONL, and NTOHS, HTONS, present in the majority of TCP libraries. 3.1 Example exception to recommendations. In certain exceptional circumstances, usually involving high-speed networks and or low-speed processors, the cost of byte reversal when sharing data between 2 little endian machines may outweigh the cost of developing, testing, and maintaining the 2 code paths necessary for runtime selection of byte order. 3.2 Network bit order. For certain low-level protocols or compression-oriented media types, bit order may be an issue. When possible, big endian is encouraged for consistency with network byte order. 4. Security considerations. Security-sensitive code, which allowed selectable byte order, would have 2 code paths to verify for correctness rather than 1. Otherwise, byte order has no impact on security. Multinational considerations. Some coded character sets, CARE policy, have more code points than would fit on a byte. When a multi-byte character encoding scheme is used, the byte order issues in this memo apply to that encoding. An octet-based character encoding scheme, such as UTF-8, can avoid these issues. 6. References. CARE policy, ALVE, strand, H period, within quotes, IETF policy on character sets and languages, close quotation, RFC 2277, UNINETT, January 1998, within square brackets, IEN-137, Cohen, D, period, within quotations, On Holy Wars and a Plea for Peace, end of the quotation, IEN 137, USC /ISI, April 1980. End of page 3. On to page 4 of Internet Draft Network Byte Order, February 1999. TIFF within square brackets, Parsons G RAFFERTY, J period, ZILLES, S period, within parentheses, within quotations, or quotation marks, tag image file format, TIFF, dash image / TIFF, MIME, subtype registration, end of quotation, RFC 2302, Northern Telecom, March 1988. Or 1998, not 1988. 1998. Keywords. We have BRADNER, S period, within quotations. Keywords for use in RFCs to indicate requirement levels. End of quotation. RFC 2119, Harvard University, March 1997. Within square brackets, UTF-H, YERGEAU, F period, within quotations, UTF-8, a transformation format of ISO 10646, end of quotation, RFC 2279, ALIS Technologies, January 1998. And then we have authors' addresses. 7, Chris Newman, Inusoft International Incorporated, 1050 Lakes Drive, West Covina, California 91790 USA. Email chris.newman@inusoft.com. And I think that's the whole thing. And yeah, expires August 1999, which was a long time ago. And that is the end of the draft on network byte order.